Dear students, in this session we will discuss about parallel connection of two-port networks. See, we will connect two-port networks in parallel. So in these connections, for representing the interconnection, we are using admittance parameter or Y parameter. Suppose we are having two-port networks X and Y. You know that for the X network there will be one input port and one output port. Similarly for Y network also there will be one input port and one output port. Okay. So in the case of parallel connection, suppose in the case of input port, suppose this is the reference node. For the case of X network, for the output port, if this is the reference node. Similarly for Y network, if the reference node for the input port is this, and similarly for the output case, the reference node is this. In the case of parallel connection, we will be connecting the reference node of X with the reference node of Y. Similarly, here also there is a connection in the output side. So, these reference nodes are connected together. Similarly, the other input nodes are connected together for the X and Y network. So, the rest of the part is this one. So, this is connected together and this is also connected together. So, this is the parallel connection of the two-port networks. Okay, X and Y are now connected in parallel. Here the reference nodes are connected such that also other nodes are connected together. So, they form a parallel combination, and here the reference node is the same for both the networks. So, in the case of parallel connection, here is the explanation. If we have a two-port network X and Y, X has a reference node for its input and output ports. Similarly, Y has a reference node for its input and output port. In parallel connection, reference node of X is connected to reference node of Y. Reference node of X is connected to reference node of Y in the output side also. So, the two ports are connected so that they have a common reference node. Now, the common reference node is this one. Okay, this is the common reference node. Okay. So, here we are marking the different values. Here, these two are connected together. Let the current be I1. Similarly, these two are connected together. This is current I2, and here the reference node is here, and its voltage at this node is V1. And here these two nodes are connected, so it acts as a reference node. So voltage across these two terminals is V2, and here I1x is shown here and I1y is shown here. Similarly, I2x and I2y is shown here. So V1x is the port voltage at this input port, and V2x is the port voltage at this output port of X network. V1y is the port voltage at the input port of Y network. V2y is the output port voltage at the of the Y network. Okay, so let us see. First of all, we will here for the parallel connection we are using admittance parameter. You know that in the case of admittance parameter we are representing the input current of two ports, that is I1 and I2, in terms of V1 and V2. That is the speciality here. If we are considering a single port X, then the I1 and I2 of this X will be represented in terms of V1 and V2 of this port X. Similarly, for the Y network, I1 and I2 of this Y network will be expressed in terms of V1 and V2 of this Y network. So, if we are considering the networks or ports X and Y networks differently, individually, then we can write the equation for I1 and I2. Here there are two networks, so we are representing I1x and I2x. Similarly, we are representing I1y and I2y. So, for the X network, the currents are I1x is equal to, we are representing Y11x V1x plus Y12x V2x. So, for the I2x equation, Y21x V1x plus Y22x V2x. In the case of Y network, the two equations are I1y and I2y, and I1y is expressed in terms of V1y and V2y. I2y is expressed in terms of V1y and V2y by using Y parameters as here. You know the equations, that is it will be expressed in y11 y v1y plus y12 y v2y, y21y v1y, y22y v2y. So this is the equation when we are considering the two ports individually. When we are connecting it parallel, so that combination will become a single one. So suppose in that parallel combination, V1 is the voltage, I1 is the current here, and I2 is the output current, and V2 is the output voltage. So we are expressing I1 and I2 in terms of V1 and V2. You know that in the case of parallel connection, port voltages will be same. That is V1 and V2 will be the same, right? So we can write V1 will be equal to V1x, that will be equal to V1y. Similarly, V2 will be equal to V2x, that will be equal to V2y. That means when we are connecting the two networks in parallel combination, then the port voltages will be same. That means V1x will be same as V1 and V1y will be same as V1. Okay, similarly V2x will be same as V2. Okay, V1y will be same as V2 because V2y is the voltage between this terminal and this terminal. See, you can see here, this is the same terminal here. So V2 is the voltage V2y. Similarly, V2 is the voltage V2x. So when you are going for this I1x equation, you can see here that here is a term V1x and V2x. But in the parallel connection, this V1x and V2x are same. That is V1 and V2. So you can represent it as I1 will be equal to y11x V1 plus y12x V2. Similarly, I2 will be equal to, what is I2x? I2x is y2x V1x plus y22x V2x. So you can write I2 will be equal to, what is I2? I2 will be equal to, here before that you have an equation I1. What is I1 equation? See, in the case of parallel combination, I1 is the current through this port and current through this port. See, what is its equation? Equation is I1x and I1y. So it's a sum. In the case of parallel combination, I1 will be the sum of I1x and I1y. Here the sign is reversed because the symbol is not correct here. I1 should be flowing inwards. Okay, so I1 will be equal to I1x plus I1y, and I2 will be equal to I2x plus I2y. So here is an equation, I1 equal to I1x plus I1y, and I2 will be equal to I2x plus I2y. In the case of parallel combination, that we have studied in the first year classes, because in the case of parallel connection, currents will be summed and voltages will be equal. Okay, for the parallel connection. So I1 can be written here, instead of I1x we can substitute this equation. Okay, that is written here, but here you know that V1x and V2x are V1. So you can write this equation like this, and similarly next term is I1y. I1y is this equation. Okay, so that is written here, but here you know that I1y, V1y and V2y are V2. V1y and V2y are same, that is V1 and V2. So you can write a V1 and V2 terms right here, and here you can take the common terms outside. So you will get a y11x plus y11y into V1 plus y12x plus y12y into V2. So you can similarly another equation is I2 will be equal to I2x plus I2y from the parallel combination. Here I2x is equation this one, and here you know that V1x is V1 and V2x is V2. So you are writing the equation like this. Okay, similarly I2y is this equation, and here V1y is V1 and V2y is V2. So you can write the equation. Here you can take the common terms outside. Here V1 is common in these two terms. So you will get a y21x plus y21y into V1 plus y22x plus y22y into V2. So now you have two current equations. So in the case of a simple network, you can see, you know that when you are writing impedance parameter, I1 and I2 equation will be y11 V1 plus y12 V2, y21 V1 plus y22 V2. So if you are considering the parallel combination as a single network, then the current equation will be like this. So when you are comparing this equation with this, you can see that y11 equal to y11x plus y11y, y12 equal to y12x plus y12y. Similarly, y21 equal to y21x plus y21y. y22 equal to y22x plus y22y. What is its meaning? So in the case of parallel connection, you can say that y parameter of the parallel network is the sum of the corresponding y parameters of the individual network. So that is the point here. In the case of series connection, we are using Z parameter analysis, and in the case of parallel connection, we are using Y parameter analysis. In both these, we can say that the sum of the individual network parameters will give the total network parameter. So here, when we are going to the Y parameter of the parallel network, it is obtained by the sum of the corresponding individual Y parameter of the network. Okay, that's all about this topic. Thank you.